This is Dr.T Vara Lakshmi. I'm discussing you about the isoquants, isocosts, marginal rate of technical substitutes, and least cost combination of inputs as a part of the business economics and financial analysis. So these are all after knowing the productional function, and while applying this productional function to the work in progress, it is better to understand the some of the inherent elements in the productional function. So that inherent element in the productional function is isoquants. So generally, iso means equal and quants means quantities. In every productional function, the equal quantities for the different combination of the inputs and that relationship of the inputs to the output to yield the same quantity of input should be known by the manufacturer. Because once if we take the example that one unit of the capital plus 10 units of the labor will leads to the 10 number of output. Then, unfortunately, the labor shortage is occurred in this pandemic situation. What has to do? The labor might be reduced to 5. Then obviously, he has to replace this labor with a number of inputs. So let us say 2 units of the capital, that is introduction of the machineries using this capital, might replaces the 5 number of the labor, but that yields the same number of output. Now, the producer is thinking about this combination of these inputs and their relationship to get the same quantity. If he has the idea, then at any eventualities or at any situations, easily it is better to change for the any events that are occurs in the market. So that's why isoquants is a concept of giving an analysis of various combination of the inputs and that yielding for the same quantity of output by the producer is called as the isoquants. So these are all the 2 graphical representations that gives information about the isoquants map for the 2 inputs which are perfectly substitutable, which means if the labor is substituting with the machines, then in these 2 elements, obviously one input will be replaces with another input. So that here we can get this kind of the plotted graphs on the isoquants curves. Then, if the inputs are all perfectly complementaries, so if the machineries are all there, let us say machineries are all there, then the another technological input has to increase, and because of this machineries, the another technological inputs has to combinedly attaching towards that production. So which means these 2 are going to be complementary products. At these cases, this if they have to get what is the combination of this one inputs to the another input, graphical representations will be plots like this in the graphical representation. So that is the combination of different inputs, either maybe the substitutes or the complements, which yields the same quantity of output is called as the isoquants. So this isoquants is also called as isoproduct curves or equal product curves for the different given types of the inputs. So once if we observe the assumptions and applications of these isoquants, always it assumes that only 2 factors or the input two input factors are going to be changing in the productional. So because it is very easy to know with one variable substitutable to the another variable or one variable complementary to the another variable. If it is a multiple factors, that impact on the output measurement may not be possible. So that's why in always the isoquants is relies on 2 variable input factors, and that too they might be the substitutes or the complementary products. Then the factors of the production are divisible into small units and used in various proportionate. So which means they are able to divisible. For example, labor 5 members, 6 members, and the small units are also can be divisible, and 10% reduction in this machineries and 10% reduction in the technology. Like this, it should be able to divisible. And technical conditions of the production are also not possible to change at any point of time. So which means if two variables are all changing in the productional function and the third variables remains constant. If not, it will become a multiple variant and may not give the accurate measurement of the quantities impact by the inputs. So that's why the other elements remains constant like the technology, and different factors of the productions are used in a most efficient way, and how they are, why they are going to be combining or the changing or the replacing should be known under the isoquants, and that clarity must be there for the existence of these isoquants. So these are all the assumptions of the isoquants. That is, it think about the two variables and there is no a third variable, and if the third variable is there, it should be constant, it should not be a variable element, and the best combination quantities and the small elements combinations is very important for the isoquants. Okay, so when they will apply this concept of the isoquants means, so if the producer is there, he has to adjust the inputs against the outputs, but he has to get the same quantity of output for the given producer's budget. At that situations, he will apply the concept of isoquants and its impact on the productional elements. And to analyze the every microeconomy factors that are influencing the productional elements, and unfortunately, if one input shortage is occurred, or then the producer should know the replaceability of the another input. In all these situations, to fit the productional element into the producer's budget, it is very useful for the producers to, by the understanding of the isoquants position of the productional function. So that is the assumptions and applications of the productional function. There. So once if we see the basic properties of the isoquants curves, they can tangent or intersect with one other because they are all substitutable. So if one is going to be reducing, then automatically another elements will be increases. So that's why there is no chance of the tangent or intersection. And next thing is, an isoquant curve slopes downwards because it is going to be replacing with another elements. If one is reduces, another one will be increases. And an isoquant curve, because of this marginal rate of technical substitution effects, it is convex to the origin because it won't touches the any of the lines, because the labor completely not become zero and capital will not be become zero. They just the combination of the capital and labor only changes. So they do not be parallel, and they should not, they will not be overshaped or overlapped. So these are all the properties of the isoquants. Same thing, if the instead of the quantity production, the producer also has to think about the cost element, because the expenditure should not change for the producer. As a producer, if he thinks about the expenditure elements in that same expenditure or for the different combination of that inputs, then it will be called as isocost. Isocost, that is equal cost for different combination of the inputs is called as the isocost. If 10 units of the capital and 50 units of the labor cost, let us say 4 lakhs pounds for the production of that one, and same 30 units of the capital, and here the capital is increased and the labor is reduced. So this combination of these inputs may also gives the same expenditure for the producer. Then that combination of the inputs that yields same expenditure levels of the production, that is called as the isocost. That is the combination of two factors. Again, here is also the two factors that cost the same to the producer. Then that combination of the input production function elements is called as the isocost. So once if we see this formula, or the formula for this isocost is cost of the production is equals to price or the wages paying to the labor into the number of labors plus rate of interest which is paying for the capital plus the capital which is using. So that is total inputs and expenditure which is incurring on that inputs is equivalent to the isocost, cost of the production. So anyhow, if they are using 10 number of labors, 10 into, for each labor they are paying 1000. So 10 into 1000, 10,000 plus they are using the capital of 20,000 including the interest rates of 5,000, 25,000. So 10 plus 25,000, 35,000. So that is the total cost which is incurring for the productional function. So in the isocost, if they want to know the cost of the production, that is equivalent to one input, one input and the expenditure incurring to that input plus another input and the expenditure which is incurring to that particular input. So that has to shown, and this is the mathematical expression which is using to estimate the cost of the particular isocost curve in the productional function. So once if we observe the relationship between the isocosts and isoquants, mostly in both the situations, the two factors are all changing. That is one input to the another input. Either may be a substitute or maybe a complement. But so in terms of the quantity it represents, then it is called as the isoquants, and in terms of the cost it represents, it will be called as the isocost. So same example, if we see various combination of these methods like A, B, C, D, E, F, G. So in all these cases, in A case, the number of the capital plus number of elements of the labor, 18 and 2. So at that situation, they are able to produce how much quantity of the goods, and at that time the cost which is incurring to that particular goods, and the next level of the outputs, and what is the quantity which they are able to produce, and the expenditure which is able to incurring on that particular level of production. So same at a time, every producer can plot the isoquants and isocost combinations, because not only the quantity, even the cost is also important element in estimating the profits by the producer. So that is the importance of the isocost and isoquants curve for the producer in applying or in getting the maximum profits by the producer. The next element or basic important factor considering by the producer is marginal rate of technical substitutes. That is, in the isoquants and isocosts, how much percentage of one input factor impact is there on the other factor is going to be measuring in terms of the marginal rate of technical substitutes. For example, in isocosts or isoquants, 10% increasing in the capital can reduce the 10% reduction in the labor. So which means the rate of the one input's impact on the, that is the capital impact on the another reduction value for the another input, or 10% increasing in the capital may leads to only 5% reduction in the labor or 15% reduction in the labor. So which means at what rate the one input is going to be impacting the another input is called as the marginal rate of the technical substitutes. That is, MRTS is equals to change in one input divided by change in the another input. That is, change in the capital divided by change in the labor, or instead of the total one, we can take the marginal production. So marginal production of the labor divided by marginal production of the capital. So that is delta K divided by delta L. That is, K stands for the capital, L stands for the labor, MP stands for marginal products of the each products. So that rate of one input to another input is called as marginal rate of technical substitutes. So here is the tabular explanation for the marginal rate of technical substitutes with the different combinations. So let us say at A combination, 1 unit of capital and 12 units of the labor is going here. It is the base one. It's the basis of this one. Here no change. And in the second combination, if the 2 capital plus 8 labor will lead to the marginal rate of technical substitute of 4. That is, 4 labor is reduced divided by 1 capital is increased. So 4 MRTS is 4. And here again 1 more unit of the capital is introduced and the labor can be reduced by 3. So 3 divided by 1 will give the 3 MRTS. And if one more unit of the capital increases, that leads to the 2 decreasing factors, 2 units of the reduction in the labor, that is 2 divided by 1, that is equals to 2. So for example, if it is 5, then we can say 2 divided by 2, that is 1. So that is at initial, generally in any of these graphical representations, initial stages of this MRTS will be more. When if it is continuing like this, then obviously that will be diminishes the marginal rate of the technical substitutes for the given input factors. So that is the use of this marginal rate of technical substitutes, and the impact of one inputs on the another input is clearly plots with the help of this marginal rate of technical substitutes. So the next thing is the applicability of the marginal rate of technical substitutes. For example, we went for the shopping and we are seeing 2 bags. So one is a very beautiful and bigger one. Another one is a blue color one, or a small one, but it's very cute. Then we will start. Which one have to purchase? If I purchase the first bag, what is the positives, pros and cons? That is positives, elements. What is its price? What is the material? What is my purpose in that one? And if that second thing is going to satisfy the purpose, price, elements, obviously we will compare that one with one input to one bag to another bag. So same way, as a manufacturer, he has to compare what is the first input and what is the next input. Can he substitute it or not? If he substitutes, what percentage of benefit is gaining by the producer? Is it under the budget of that producer or not? Is it going to be yielding the same output or not? Is it going to be give the same expenditure elements to the producer or not? So all these cases, a producer should know the should have some information about this marginal rate of the technical substitutes. So that is the important and significant factor of this marginal rate of technical substitutes. The next element or the next important element for the producer is to know about the least cost combination of inputs. In the marginal rate of technical substitutes, as a producer, he came to know at what rate that one input will be substitutes with another substitute. Then, if he will get a maximum number of combinations. In that combinations, again, what is the best combination is identifying with the help of the conceptual knowledge regarding the least cost combination of inputs. So let us say, so there is A combination is there, B combination is there. In this A combination, so the combination of inputs that cannot be produced the same quantity, or in this B combinations, C combinations and B combinations, it cannot be able to give the same cost, but at the A combination, same cost, same quantity, but the combination of that inputs is giving the more benefits to the producer, then he can go for this A combination of the inputs than the B and C. So here he is analyzing the various marginal rate of technical substitutional elements and the combination of the inputs and choosing the best one for the production implementation to the productional elements. That is called as the least cost combination of inputs. So here under the least cost combination, as a producer wants to take the decision, he must follow that the slope of the isoquants must be equivalent to the slope of the cost. That means quantity and cost should not be changed, and the combination, if both are not changing, then the combination of that inputs is the maximum way to give the benefits to the producer. So that is the decision's point of rule for the producer, that where the slope of the quantity is equivalent to the slope of the cost, and that is the best combination to take a best decision regarding the production of any product. So lowest combinations will leads to the change in the quantity levels or leads to the change in the cost levels. So that's way while taking the decisions based on the least cost combination of the inputs, he has to see the sloping curve of the isoquants and isocosts. So that's about the isoquants, isocosts, marginal rate of technical substitutes, and least cost combination of inputs and their usage to the producer in plotting of a productional function. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.